Guys, please let us consider another example. Let us consider another example, saying simply supported beam, supported beam subjected to a UDL, and is also subjected to a point load 50 kilonewton at exactly the center. This is point E and this is point B. So this is unit load, what is UDL is 10 kilonewton per meter. So you need to find out. What is the deflections at point C. Deflections at point C means what is delta at C. We need to find out at midpoint. So this is 5 meter and this is 5 meters. So here in this examples we need to find out what is the deflection at point C. You need to find out what is the deflection at point C. So they may ask find out what is the deflection at point C by using unit load method. So now in first step in unit load method, so as usual, so what is the deflection due to unit load formulas? Delta equals to 0 to L capital Mx small mx by EI into dx. What is capital Mx here? Bending moment due to external load. Small mx means what is the bending moment due to bending moment due to unit load. So the first let's find out what is the capital Mx bending moment due to external load, then go for what is the bending moment due to unit load. So now let us consider the same beam. So first we need to find out what is the reactions for the sections. Now so let us find out the reactions. Let us find out the reaction. What is the reactions? So what is RA and RB? So you can use sigma Fy that equals to 0, RA plus RB that equals to 10 into 10 plus 50. So it is 150. Take equation number 1. Then use sigma MA that equals to 0. RB into 10 that equals to how much? RB into 10. So this will be what? 10 into this will be 10 into 5 plus 50 into 5. Then what is the RB? RB equals to, if you calculate, you will get 750 divided by 10. So it will be 75 kilonewton. So if you substitute in equation number 1, you will get what is RA. RA equals to 150 minus 75. It is also 75 kilonewtons. So if you are clearly see this, it is a symmetrical section, symmetrical beam. So if you cut exactly the center, left hand side equal to right hand side, so directly you can write total load divided by 2. So total at 10 into 10 plus 50, so it is 150 divided by 2. This is 75 kilonewton. Like this also you can calculate. Now so as I said earlier, so what you have to do, you need to calculate what is the bending moment due to the external load capital Mx. So let us take a portions. These are two portions are there. Let us take a bending moment at these sections in left hand side portions x-axis, and you need to calculate what is the bending moment at these sections in the AC portion. So here also let us take another sections x-axis at a distance x from the point B. Same procedure, guys, please. Here we need to find out what is the bending moment at these sections and each portions. Here I have AC portion and BC portions. Now so I calculated what is RA is how much? 75 kilonewton. What is RB? RB is also 75 kilonewton. Then calculate what is the bending moment in AC portion. Calculate what is the bending moment at x-axis. What is the bending moment at x-axis? 75 into x minus of 10 into x by 2, right? Similarly in this here also, what is the RB? RB is 75 kilonewtons. What is bending moment at x-axis? Due to the external load into distance, RB into x, then 10 into x by 2. So here it's symmetrical. Bending moment at this section AC portion is same as what is the bending moment at BC portions. Now let us same thing. Now calculate capital Mx. So what is that? Bending moment in AC portions, due to the external load, that equals to Mx is bending moment in BC portion. Then capital Mx equals to what is that? 75 into x minus of 10 into x by 2. So if you write, this will be 75x minus 5x square. This is your capital Mx for both portions, for AC and BC portions. Then what is your next step? This is that's how we need to do it. Then what is in our next step? Next step is take a same beam. So here you remove all the loadings and apply unit load at the point where you need to calculate your deflections. So this is point A and this is point B. So here I need to calculate what is the I need to calculate. Here you can see, guys, please, this is a beam. You remove all the loadings for the given beam, and the point where you need to calculate your deflections, apply 1 kilonewton. 1 kilonewton. The same thing I did it here. This is a 5 meter and this is also 5 meters. Same procedure, guys, please. So you need to take a section in AC portions at a distance x from this portions. Here also xx at a distance x from this end. So what is before that we need to calculate what is the reactions RA and RB. So I can easily calculate RA, that equals to RB, total load divided by 2. So what is total load? 1 divided by 2, it is 0.5 kilonewtons. So RA is 0.5 kilonewton. RB is also 0.5 kilonewton. Now calculate what is small mx. Small mx equals what? Bending moment due to unit load. Small mx, bending moment due to unit load at the sections. Mx in AC portion, that equals to mx in BC portion. Then you calculate small mx equals to 0.5 into x. So it is 0.5x. Now we know that what is the deflections. Deflection delta equals to 0 to L capital Mx into small mx divided by EI into dx. So 0 to L means what is the limit here? We can see for each portion what is the limit. For AC portion is also 5 meter, for BC is also 5 meter. It is symmetrical, and so I can write this formulas. 0 to 5, capital MS is 75 x minus 75x minus 5x square. Small mx is 0.5x divided by EI into dx. Now total there's a two portions are there, so I need to multiply with the 2. So it is symmetrical is there. If it is not symmetrical, so you need to write another formulas for on this side. Okay, so it is symmetrical one. You can say this is symmetrical one. Bending moment due to unit load and bending moment due to external loads are same on both sides, so I can write like this. So total into two portions are there, like this I need to do it. Now you integrate it. So whatever the given values, so you integrate it. So 2 into 0 to 5, so it is 75x 2 by EI, you can take outside 75x minus 5x square into 0.5x dx. So now we can write this 2 by EI. So we can write this 0 to 5 37.5 x square into dx, minus 0 to 5 2.5 x cube into dx. We integrate it. So guys, please, you integrate it, you will get. So you integrate it, you integrate the values. So you integrate the values. At the end, I will get. You integrate the values. At the end, I will get delta equals to 2343.74 divided by EI. You will get deflections. if and you will get the deflections. Then if you integrate it, you will get delta equals to 2343.745 EIs. So guys, please, if you want to cross check, you can see it is simply supported beam subjected to UDL and have subjected to point loads. So if you want to cross check this, it is a symmetrical one. It's just like a simply supported beam subjected to UDL, and another is what simply subjected to a point load 50 kN exactly the centers. So if you want to cross check these values, you can do like this also. Delta equals to what? 5 by 384 WL raised to 4 by EI. This is due to UDL plus WLQ by 48 EI. This is for check. This is for check. If you do like this, you can easily find out what is the value. You also do like this, you will get 43.75 divided by EI you will get. So there is no that much of change. So this is standard check. You can also do it because it is what symmetrical one as standard cases. Simply supported beam subjected to UDL and simply subjected to a point load. So you can cross check with values and you will get delta equals to this value. So this is how we need to do it. You need to find out what is the deflections at the center using unit load method. Using unit load method. So using unit load method. Now let us consider another example. This is what trusses. So let us consider another example. Let us consider another example. What is this? So here we need to find out. This is a truss example, guys. Please, this is a truss. So you need to find out the deflections by using unit load method. By using unit load method. So consider this. This example. Consider this. Determine the horizontal and vertical deflection at joint C, means this is joint C where we need to find out deflections at joint C for the frame loaded as shown in figure. Cross section area of horizontal, vertical and inclined member are 1500, 2000 and 4000 millimeter square respectively. Take E equals to 2.1 into 10 raised to 5 Newton per millimeter squares. This is given example. We need to find out what is the deflections for the truss at the point C. We need to find out both horizontal and vertical deflection at point C. So this is how we need to do it. So you already know that what is the deflections. What is the deflections of trusses by using unit load method. So what is how to find out this one? You can check here. So we can find out what is delta equals to in trusses. I can find out delta equals to PKL by AE. Delta equals to, so if you want I will write here, you can check. So what is delta in trusses? So that is summation of PKL by AE here. This is delta. How we to find out delta equals to in trusses. How we have to find out deflections? That equals to PKL by AE. Here P is what? Member forces due to the external load. K is what? Member forces due to the unit load. L is length of the member. A is cross sectional area, and E is the Young's modulus. So I can find out delta equals to summation of PKL by AE. So for this, please you can see these formulas. Delta equals to PKL by AE. For what is that P? P is what? Member forces in trusses. So your first step in unit load method. So you are finding the deflections at different point. Means your first step is you need to find out what is the member forces due to the external load. Then you need to find out what is the member forces due to the unit load. Then you need to find out what is the deflections. Okay, the step you need to follow. So now let us take this example. Already shown you. So this is a truss. So A, B, C, D. So we need to find out what is the deflection at this point, and is subjected to a vertical load of 180 kN and a horizontal load of 80 kN. So as soon as you see the problems, your first step is to find out the support reactions. So let us say I assume like this. So it is a hinge portion, so I will get two reactions, and this is roller one, so I will get only one reaction. Then use equilibrium condition, sigma fx equals to 0. Then find out the what is the reactions. What is the horizontal reaction? HA I got 80 kilonewton. Is a minus, means it is acting in this directions. Is a assumed direction is wrong, so it is acting in this directions. Left hand side it will act. Then similarly take sigma ma equals to 0. Find out what is RD. I got reactions RD equals to 260 kilonewtons. Then use sigma Fi equals to 0. Then find out what is the RA. So this reactions, vertical reaction you will get. The RA I got 80 kilonewton, means my assumed direction is wrong. RA I assumed that in acting upward directions, but no, it's acting in downward. Why I got it's a minus. So my assumed direction is wrong, so it is acting in downward directions. Okay guys, now as I said earlier, so what is delta in trusses? Delta equals to summation of PKL by AE. PKL by AE. What is P? P is what? P is what? Member forces. We need to find out forces in each members due to the external load. Yeah, I got the reactions. Now take each joints. You can use how to find out. You can use method of sections or method of joint to find out the forces in each member. So let us say I am using method of joints to find out what are the forces in each members. For this, what you have to do, I need to select a joint, any joint. I need to select the joint in such a way that you should not contain more than two unknowns. I can select this, I can select this, I can select this, I can select this. So let us, I selected the joint C. I selected the giant D, so it has only two unknowns. What is that? F of dA and F of dC's are unknowns. Already I calculated what is RD. RD I calculated is 260. RD I calculated is 260 kilonewtons. Now I consider giant D. I draw the free body diagrams. Please remember another thing. So whatever the unknown forces are there in method of giants, we need to assume that it is you need to assume that they are in tension. So that's why I shown the arrow mark in upward directions. Here upward, and that's why I shown the arrow mark. It is moving away from the point, a reference point, moving away from the reference points. Okay. Now use equilibrium conditions. It is a coplanar concurrent force system, so use equilibrium conditions. What is the equilibrium condition? Sigma fx equals to 0 and sigma fi equals to 0. Then you use sigma fx equals to 0, so the f of dA equals to 0. Similarly, I use sigma fi equals to 0 plus 260 and plus fdc. I calculated what is fdc value. Okay. Then similarly consider giant, another giant A. Similarly you consider another giant A and draw the free body diagrams. Any inclined forces are there, you resolve along horizontal and vertical directions. So these two are unknowns here. I already calculated what is f of dA, that is 0, right? F of dA. So here we calculated what is that? Here you calculated what is f of dA is 0. So means, so here we calculated force in this member is 0. So I can directly put, so at the joint A, I can draw the free body diagrams, and I show this is already calculated reactions. RA is acting downward 80 kilonewton, and HA is acting on left hand side 80 kilonewton. Why? Because it is minus. I got minus, right? Minus. So these two are unknown. So let us say the forces in this member first. Earlier I assumed that force in this member are tension, means your arrow mark should be moving away from the point. You need to show the arrow mark should be moving away from the points. Then use sigma fx equals to 0. I got FAC equals to 113 and sigma FAB equals to 0. FI equals to 0. I got FAB equals to 0. Similarly, consider another giant B. So this is giant B. So f of AB, here you can check. Guys, please. F of AB is 0. You left with f of BC. So here I can directly take sigma fx equals to 0. Then f of BC equals to 0. BC equals to 0. Like this, we need to find out forces in each member due to the external forces. Then what is your next step? Next step is to finding the vertical. So please remember your next step. Well, in the next steps, let's say I am finding vertical deflections. First I am calculating what is the vertical deflections. Let's take for vertical deflections. Then what you have to do, remove all the external loads in the trusses, then apply unit kilonewton at the point C where you need to find out the deflections. So same thing I did it here. You can check. So in the trusses, I removed all the external forces and I applied 1 kilonewton unit vertical. So 1 kilonewton vertical directions. Please remember, you cannot apply horizontal deflection. You are finding vertical deflection means you need to apply 1 kilonewton vertical acting downward, vertically acting downwards. So you need to apply 1 kilonewton is acting vertically downwards directions. Okay, because it will deflect in downward directions, right? So then you need to apply what is it 1 kilonewton acting downwards. So please remember, so the point where you need to calculate vertical deflections, there apply 1 kilonewton vertical force, 1 kilonewton vertical force, the point where you need to calculate deflections. Then so then finding the vertical deflection due to the unit load applied vertically, unit load. So I given here you need to apply unit load, so vertically. So now, so I removed all the loads and I applied 1 kilonewton in vertical directions. Now the same step you need to repeat. You need to find out the support reactions. Then consider each joints and you need to find out the what is the forces in each members. So what we did earlier, force due to external load, same thing we need to repeat here. Same thing you repeat once again. Then I by considering different joints, I calculated what is the forces in each member. What are the forces in each member? So here I consider joint C. So I drawn this. I calculate what is F. Here you can check. So I consider joint C. I calculate what is FAC and FCB and FE. This is due to the 1 kilonewton vertically acting downwards. So I calculate once again the forces in each member due to that 1 kilonewtons acting vertically downwards. Then so I am also finding here. So for the given problem we can also check. So they also ask find out what is the horizontal deflections at the they also ask what is the horizontal deflection at point C. Then what you have to do, then you need to once again remove all the loadings in the truss, apply 1 kilonewton horizontally at the point C, horizontally at C. The same wording is given, you can check here. Finding horizontal deflection at C due to the unit load applied horizontally at C. Now you applied horizontal 1 kilonewton point C. Then repeat the same procedure, guys. Please repeat once again. You need to find out the reactions and select each joint. You need to find out the reaction and select each joint and find out the what is the forces in each members. Same thing I did it here. We can check. I select the each joint and I find out the what is the forces in each members. Then our last step is to we need to tabulate the result. Our next step is to we need to tabulate the result. So here you can check members. What are the members in trusses? A, B, B, C, C, D, D and ACs. Then what is the load? What is the forces in each member due to the external load? P. What is P? So this is 0 I got, minus 260 and all this. Then this is that forces due to unit load. So I applied vertical unit load. Then these are all the forces I got. Similarly, I applied horizontal load and these are all the forces I got. I tabulated here. Guys, please, if they ask only vertical, you need to find out only, you need to apply only vertical 1 kilonewton and you need to do this. If they ask horizontal, only do this much. If you have vertical, no need to do this one. In this problem they ask both, that's why I calculated both. Now this is the length of the members. So length of the member 400, 4000, it's in mm. So this one given. Area of cross section is already mentioned in the problem. So write down all those things. E is what? 2.1 into 10 raised to 5. It is also given. Then calculate delta equals to what? PKL by AE. Now you calculate what is delta of each members, means deflection of each members. Calculate this thing. Then what is the formula I have to use? Delta equals to PKL by AE. Let's say now calculate what is the vertical deflections. Vertical deflection means you need to take external force and vertical forces. PKL is what? Due to the unit load, due to the unit vertical loads. If you are finding that, you need to take. Then find out what is the delta for each thing. Means for this what you have to do? P is 0. What is K? K is 0. What is L? L is 400. That this term is 0 means this is also 0. Similarly, here you can check if you are finding vertical deflections. So what is the P is minus 260. What is vertical force? Minus 1. into L is what 4000 divided by AE. AE is how much? 2000 into 2.1 raised to 5. I will get 2.476. Similarly, here also I will get 0 because both terms are 0. Here also I will get 0 because vertical forces here are 0. So like this we need to tabulate it. Similarly, you need to find out deflections due to the horizontal unit load. Find out the deflections. Find out the deflections by using this formula PKL by AE. So each member you need to find out the deflections. Now, then what is the vertical deflections? Vertical deflections. Delta CV equals to summation of all those things. Summation of deflection of each member. So delta CV equals to summation of PKL by AE. So it is 2.476 mm. So you need to do the summation of all the things. I will get 2.476 mm. Similarly, what are the horizontal deflections? Delta CH equals to summation of PKL by AE. It is 3.55 mm. This is how we need to do it, guys. Please. So please, if they ask horizontal deflection means you need to apply here. You remove all the loading, apply 1 kN horizontally at this point and find out the forces in each members. If they ask vertical deflection means you need to remove the all the loadings and you need to apply 1 kilonewton at the point C vertical force at the point C. This is how we need to do it. Thus you need to remember, guys, please. Okay, this is how we need to analyze the trusses. That's how we need to analyze the trusses. Thank you, guys.